Okay, so in today's video, we're going to talk just about the basics of arc length here. One of the biggest things to understand here is the difference between arc measure and arc length. And I think one of the most helpful ways to kind of think about this is with a clock. So if you were to look at a clock and imagine one of the hands going from the 12 o'clock position to the 4 o'clock position. If we can do a little bit of math, and you can see the math is here, you would find out that that is 120 degrees. And it wouldn't matter if that's the hour hand or the minute hand or the second hand, they'd all be going 120 degrees. That would be the measure of that arc. And the difference between the measure of the arc and the length of the arc is that the length of the arc is the actual linear distance traveled. Things like inches and feet are going to be the units for arc length. And in that case, you can see if I have the minute hand out here on the pink line and the hour hand in the blue line, the minute hand actually travels a greater distance than the hour hand. Its arc length is longer than for the hour hand. Even though the measure of both of those arcs is 120 degrees, the length traveled by the minute hand is bigger. And so that's the big thing to think about here. So when we're looking at finding the arc length, the biggest thing to kind of consider is that all we're really doing is taking a fraction of the whole circle. So if I look at this circle, the arc AB is just going to be 1/4 of the whole thing. You probably can look at that just by looking at it and see that that's the case. If I look at something like CED, well, pretty clearly that's a half of the circle. Now, something like this, EF, might be a little harder. It's not exactly obvious what that arc should be. But the key here is you can use the measure of the arc to help you out. We know that the measure of this arc is 120 degrees, and the measure of the whole entire circle is 360. And if we simplify that down, we get 1/3. So that's 1/3 of the entire circle. Now, when we talk about arc length, all we're doing is taking whatever fraction of the circle we have times our circumference. So if we have 1/3 of the circle, we find the circumference and multiply it by 1/3. So taking a look here, we've got basically the exact same picture here. This time they tell us the radius. So first thing I'm going to do is find the circumference. I've got 2 times pi times my radius 9, or sorry, not 9, 12. 2 times pi times 12, which is 24 pi meters. And we talked earlier about how this is a quarter of the circle. So to find the arc length, we're just going to take a quarter of 24 pi. Now, you could do this a couple different ways. If you knew that 1/4 of 24 is 6, that's great. You could treat it like a fraction and multiply straight across to get 24 pi over 4, and then go back and divide 24 by 4 to get 6. But a quarter of 24 is 6 pi. Next up, we've got this one. This is your half a circle. So again, we're going to want to start by finding the circumference. 2 times pi times 4 is 8 pi for the whole thing. And because we want half of it, CED is a semicircle, we've got a half times 8 pi. Well, a half of 8 pi is 4 pi. And that would be our arc length, this time in inches. Finally, we've got this one here. They went ahead and changed it a little bit. Now it's 140. But first of all, let's find the circumference here. 2 times pi times 36 is 72 pi feet. So for our arc length now, not so obvious what that is as a fraction, but we can always compare it to the whole circle. 140 degrees divided by 360, that's not simplified, but that is the fraction of our circle, times 72 pi. Now here, the biggest challenge is going to be simplifying that. If we're lucky, that thing would come out to be a nice whole number multiple of pi, and we could try that. So that option would be basically just to multiply the stuff that isn't pi in our calculator to leave the part that is pi. And this one does turn out to be nice. If I take 140 on the top times 72 and then divide it by 360, I do come out with a nice number. I get 10,080 pi on the top divided by 360. And if we just simplify the fraction part, we end up with 28 pi. And that is in feet, but I don't have room to write the feet, so we're just going to pretend I write the feet. That won't always come out that nice, and you'll see an example in just a little bit here of how we might deal with that when it doesn't come out so nice. So our formula for arc length is going to be this. Arc length is equal to 2 pi r times the fraction of the circle that you want. I usually prefer to write it the other way, so I'll write it as theta over 360 times 2 pi r, but it doesn't matter at all. The big thing is that theta is either the central angle or the arc measure. Remember, those are the same thing. So either the central angle or the arc measure is theta. It's just a variable we use for angles that we don't know. It'll be in degrees every single time for now. So let's take a look at a couple of examples. I'm going to just use that formula. There are other ways to do this, but we're going to start off with the formula here every time. So we've got arc length equals theta over 360 times 2 pi r. And then we'll just plug in the things we know. On these first examples, we're not solving anything. We know the things we need. So arc length equals 60 over 360 times 2 times pi times 9. And we've got some fractions to deal with, but hopefully you can be a little bit confident here and you know how to deal with these fractions. First thing I want to do is simplify my fraction. I'm looking for numbers that go into both. Every single scientific calculator out there will simplify fractions if you want to learn how to do that. But if I want to simplify this, well, one thing I could do is I could divide both of them by 10. So 60 over 360 turns into 6 over 36. And then, well, I could divide all of those by 6. So 6 over 36 turns into 1/6. The other thing I can do is I can combine the 9 and the 2. So that would be times 18 pi. If I multiply those straight across, 1 times 18 pi is 18 pi divided by 6. Well, and 18 divided by 6 is 3. So we've got 3 pi. I would highly suggest you simplify as you go, because if you start multiplying straight across here and then try to simplify, it's going to be a lot more work than if you kind of simplify as you go. Second one here, we're finding the length of this arc, and I forgot to put in the radius. We'll just say the radius is 4 here. So I'm going to write the formula. Arc length equals theta over 360 times 2 pi r. And I'll go ahead and write in the things I know. So we've got 120 over 360 times 2 times pi times 4. I'll simplify what I can here. And it turns out that 120 over 360 is a third. We saw that one already. 2 times 4 is 8 pi. Now, nothing simplifies there, but I can just multiply straight across. 1 times 8 pi is 8 pi. 3 times 1 is 3. And that's my arc length in terms of pi. We'll be leaving all of our answers in terms of pi. Next example here, they're giving us the angle BTA, and the radius is 24. So the big thing here is if this angle is 60, then the actual measure of my arc, BA, is actually double that, 120. So that's the angle that I need to use. So here I've just plugged all my numbers into the arc length formula, 120 over 360 times 2 times pi times 24, and I'll start working on that. 120 over 360, again, we've seen that one a couple times, is 1/3. 2 times 4, times symbol, 48 pi. And we can just kind of go ahead and simplify here. 48 divided by 3 is going to be 16 pi. The final ones are going to be the ones that need some algebra. So this is going to be a challenge. You got to work on these and get through these. You're going to have algebra. You're going to have fractions in that algebra, and there's really no way around this. Because we're leaving these answers in terms of pi, we can't just rely on a calculator to deal with the fractions and turn them into a decimal. So we gotta handle this on our own. So I'm going to start by writing the formula out. Arc length equals theta over 360 times 2 pi r. And I'm going to plug in the things that I know. First thing that I know, the arc length is 2 pi. 2 pi right there. So I have 2 pi equals, well, I don't know theta, 2 pi, and I do know that the radius is 6. So now I can start working on simplifying just a little bit if I can. A couple of things I could do here. I could multiply my 2 times my 6. But what I might probably not want to do here is actually simplify this theta over 360 times 12 pi. That is going to get me into some trouble if I try to start simplifying that too much. At least it might not be the easiest way to go. One other option would be to take care of one of these things at a time. This theta is being divided by 360, so one option is just to multiply by 360 on both sides. It'll cancel out there and leave me theta times 12 pi. And on this side, 2 pi times 360 is 720 pi. Now I can just go back and divide by 12 pi on both sides. They'll all cancel out here, just leaving me theta. The pi's will cancel out. And now 720 divided by 12 is something that my calculator can handle. That's 60 degrees. The final one here, I'm going to start exactly the same way. Write out my formula. Arc length equals theta over 360 times 2 pi r. I'm going to plug in what I know. Theta is 120. Arc length is 4 pi. So I'll write that down. 4 pi equals 120 over 360 times 2 times pi times r, and I'm solving for r. Here, I think it's going to be helpful to simplify that fraction, and that is one we've seen a lot. 120 over 360 is 1/3. And we could keep simplifying this on this side, but I think this is a good place where I'm just going to leave them separate and deal with them separately. So to get rid of this 1/3, what I can do is I can multiply by 3. If I multiply by the reciprocal, 3 over 1 on both sides, on this side it just cancels out. On this side, 3 times 4 is 12 pi. And I just have 2 pi r on this side now. Finally, I can go back and divide by 2 pi. That'll all cancel out over there, leaving me r. And here the pi's are cancel out, and 12 divided by 2 is 6. So you've got a couple of things here going on. First of all is just understanding that circumference or arc length is just some fraction of the circumference, of being times, fraction times circumference. The second part of this is how comfortable are you with fractions? And that is going to be probably the bigger challenge for most of you. So work on these next questions here, give it a shot, and we'll keep working on it as we go on the rest of the week.